Hey everybody, it's October week 1, and here's the OSS team with some demos. So first I'm going to go and show the changes I made with Markdown notebooks. Oh, and I gotta exit full screen for this. So what I did this week was I made it so that you can reference another notebook. So I have this notebook linked to the Basic Streams notebook. So if I click it, it'll open that notebook rather than opening a separate link. In addition to that, I also added some new styling. So these links now appear blue instead of gray. And if you visit them, then they turn purple. You can also load images from relative links. I don't have that in a demo here though. And that's it for me this week. Okay, so moving on to Christian.
Hey, so I'm going to show a new table logger related to GC and trying to provide an easy way to find whether the slowdown that you may be having in the console has to do with GC or not, which is kind of like a common question that sometimes we need to answer. And so far, we don't have like, super easy ways to answer that question. We have like technically deep and, expert oriented ways with table loggers with lots of columns. And you can kind of like navigate your way to try to finding the answer either from log files or from those loggers. This is trying to provide like a simple way of doing that. So I need to present now. Should be this window. So this is my console. I'm going to import these performance queries in Python. This is one import that already existed, but it has a new table that is called process memory. And this new table has just a few columns when it actually shows up. It does something where once every 15 seconds, right now, it shows you some very basic stats, how much memory available you have. Here I have like the default configuration. I just have 4 GB of memory configured for the worker. You can see that here in the max memory column. This is in megabytes, so 4,000. And out of that much, I have almost all of it available. The available memory ratio is like 97%. So I have almost all the memory available right now. I'm not using anything. This just started, right? And the interesting new column is this one here. Essentially, you can just look at this if you need to answer the question of, am I having GC problems? And right now, we're not doing any GC, which is good. Now, I'm going to define a little function here. This is some Python code. It's kind of complicated, but it really doesn't matter that much from the point of view of the example. The only thing that I want to have is like some way to eat memory, right? So you don't need to care about the details of this. We're going to be loading some Parquet files, but when we actually do load them, I just defined the function. I didn't do anything. We should like begin eating memory. I'm going to be reading the sample files that Amanda put together for us that are available in a separate repository. So I have this little function that is called do work, and I can say how many seconds to do work for how long. So I'm going to say 5 seconds. So I'm reading some Parquet files. This is going to be showing one little printout every 3 seconds, or it's trying to say, oh, I'm doing this, I'm doing that. It's supposed to only do 5 seconds of work, and it has already taken a little bit more than that. And the reason is that we are kind of having some amount of like, DC work done here. So it ended up taking 17 seconds. And that's because some amount of effort went to other things. And the actual loading probably I took more than 5. So if you see here, right, we did 6.5% of GC work out of a 15-second interval for doing that work. It's not that much, but hey, there's a little bit of GC happening. Now, if I increase the amount of work here and I say, for instance, let's load data for like 10 seconds. It's going to actually load more data in memory. I'm keeping these tables in memory, and I'm actually doing a select so as to materialize all the rows. Okay, so it's not just like doing read table. It's actually add select on those tables. So now we use more. Here we were doing quite a bit of GC work, right? And I'm not going to increase that. I'm going to say 15 seconds. And hopefully we will see something a little bit more intensive. Yeah, this is now actually not printing anything. If you see this going on there, there we go. Finish with 17 seconds, and now we see. Oh, here it's a little bit more red. It's 50 seconds, 50%. Half of our time is going on GC. So yeah, that's it. Hopefully we have now one simple table and one column where you can look at things that show up in red if you have too much GC going on. And if it happens, you probably need more memory, so increase the heap size of your worker. That's it.
Nice. All right. All right. Very cool. That'll be useful for analyzing performance. Next up, we have Mike Blazak.
Hi. All right. Looks like a VM, right?
Mm-hmm.
Yeah, that's the right window?
Yep. Yeah. You can see
Okay,
it.
great. Sweet. So, hey, so we've written a kind of a automated system that'll let us do repeatable benchmarks. I'll
Sorry,
show off a couple
can
of
you
the.
make that font a little bigger? Is that possible?
How's that one?
Yeah, that's better. Good.
Great. Good.
Yeah.
Hey, so this is what a benchmark file looks like. You can see that I just have a title for my benchmark. I'm gonna do a join, and I'm gonna take animal names on the left side and adjective names on the right side. So what I'm gonna do is run a generator file first that'll get me a million things to join, and then I'm gonna go actually run a script that'll take care of that join. So the interesting part, I think, is kind of like, well, how is the data actually generated? I don't know if you've seen it. There's a website called Mockaroo. Have you seen that? And that's like a sort of a free website. I mean, you pay for it and get some extra features, but you can sort of make a schema and it'll barf out some sample data for you. And maybe we don't need something that elaborate. I mean, it'll make fuzzed up email names and stuff like that, and it'll invent addresses and things like that. But we don't really need anything quite that elaborate. And we kind of do it if we wanted to, but what I do is just I have the ability to randomize things and make big lists based on finite sets, right? So I think we have this idea of like columns and rows. So if I say a certain column is a generator, it's the column that's going to tell me how many. It's going to tell me the cardinality of my row set. So the generator for this is this values column. It's a full range generation, meaning I'm just going to start at 1 and go to a million. I'm going to use a certain random number seed. So if I do anything random, like decide if I do or I don't have null values, then I can go, repeatedly print out the same values. So with that seed, like you're quite repeatable, and the order is going to be increasing. If I wanted some other order, I could pick a shuffle, or I could pick a distribution. I could have a flat distribution, a normal distribution. I do whatever I want to. And of course, there's a data type. So if we want to make a CSV file, we're just going to go dump it into join.csv. But if I want to, I can make a Parquet file and dump it out as a Parquet file. And of course, Parquet needs to know kind of concrete data types. So what this column will generate, it's the generator. We're all following the generator. So the generator is sort of for 1 to a million. For each of those rows, I'm going to go get a random number between 1 and 650. That's going to be an integer 2. I'm going to seed it, and there's a chance it's going to be null. I mean, out of 5% of these guys are going to be null, right? Same thing here between 1 and 250. That's also going to be an integer. I'm using a slightly different seed for whatever reason, and I have a similar null percentage. So if we generate this guy, right? If we let this run, I could show what that actually looks like. Maybe that's too small, but it's just a CSV file. I have the headers for the things that I created. I have 1, 2, 3, 4, 5 for volumes, and I have just some random numbers. Very fortunately, the second guy, 2, 350, the animal ID over there is null, right? So what I end up joining is a list of animals. So I have an ID for an animal. 205 is a sawfish. 204 is a pigeon, right? Fantastic. Completely arbitrary. How could it be more arbitrary? And adjectives, same thing, right? I have an adjective ID and an adjective name. Wicked is number 3, right? So 3 is wicked. So you can imagine what I'm going to do is just join these. I'm going to have wicked starfish and incompetent pigeon and stuff like that. I'm pretty sure this. I might have sort of reinvented the wheel because I'm pretty sure this is how like the Ubuntu guys name their releases, right? If we let this fly, if I go just run this code, we'll see in the output window, which I'll zoom to and make a little bigger. We go build this guy, we run it, and we loaded animals. That took 47 milliseconds. We load adjectives. That took 41 milliseconds. Loading the relation table is a million rows. So that join file took 1.7 seconds to load. Actually performing the join took 1.4 seconds. Then we're all done, right? If we go look at the actual joiner bench, if we go look at joiner bench, that's the other file that we're kind of referencing. Animals joiner is the guy we're referencing. And this is just a list of statements. So I'm going to run off and say, hey, the title of this step is imports. I'm not timing it. It's set up, and I kind of really don't care to see a time. I don't want the cluttering. Maybe I have lots and lots of setup or lots and lots of teardown. I want to see the timing. So I turn off the timing. But load animals, just like we said, hey, it's going to go read the CSV file. Go read the CSV file. These guys are all timed. I'm going to go read another CSV file. Now I have my 3 CSV files, and what I can do is join them all, right? So I'm going to join adjectives against animals based on the animal ID and the adjective ID. I'm going to go pair that down with a view, selecting out only the values, adjective name, and animal name columns. And I'm going to time that as well. And that's it. So then we end the demo. We end the bench. Everything's all printed out, and we can repeatedly run this anytime we want to. And if I go take a peek at the Deephaven IDE I have up, some of this is leaked. So you can see the result, and there's what the result looks like. And, there's a jumpy fish and a second deer and a soggy caracal, which it's kind of sad, but at least it works. So that's what we have. Yay.
All right, very cool. That'll be good for making mock data, testing things out. All right, that's all for this week. I'll see you next week. Bye.